So we're continuing our discussion of Simondon's individuation in the light of notions of form and information. We're just finishing up chapter 1 of part 1, and then we're going to begin chapter 2. So we're right at the top of page 53 of the translation. So we've been seeing in chapter 1 as a whole the criticism of the hylomorphic schema, why it's inadequate, and using that criticism of the hylomorphic schema as sort of a launching point for the development of a more adequate account of individuation. And we'll see more of that more adequate account in the next chapter. The last little bit of the first chapter that we're going to read today is about methodology. Simondon comparing his methodology with other approaches to individuation. Okay, so I can start reading. I'll read a couple of paragraphs here, and then we'll go around as usual. The essential difference between the classical study of individuation and what we are presenting here is the following. Individuation will not be considered solely from the perspective of the explanation of the individuated individual. It will be grasped, or at the very least, we will say that it should be grasped, before and during the genesis of the separate individual. Individuation is an event and an operation within a reality that is richer than the individual that results from it. Furthermore, the separation initiated by the individuation within the system cannot lead to the individual's isolation. Individuation, then, is the structuration of a system without a separation of the individual and its complementary, such that individuation introduces a new regime of the system, but does not break the system. In this case, the individual must be known, not abstractly, but by going back to the individuation, i.e. by going back to the state starting from which it is possible to genetically grasp the entire reality of which the individual and its complement of being is composed. The principle of the method that we are proposing consists in supposing that there is a conservation of being, and that thinking cannot occur except starting from a complete reality. This is why it is necessary to consider the transformation of a complete domain of being, all the way from the state that precedes the individuation up to the state that follows or extends it. This method does not seek to diminish the consistency of the individual being, but merely to grasp it in the system of concrete being in which its genesis takes place. If the individual is not grasped in this complete systematic ensemble of being, it is treated according to equally improper and divergent paths. Either it becomes an absolute and is conflated with the sunalon, or it is reduced to the being in its totality so much that it loses its consistency and is treated as an illusion. Indeed, the individual is not a complete reality, nor does the individual continue to have the entirety of nature as its complementary, in front of which it would become an inferior reality. The individual's complementary is a reality on the same order as its own, like the being of a pair relative to the other being with which it is paired. At the very least, it is through the intermediary of this associated milieu that the being is attached back to what is larger than it and to what is smaller than it. So he's continuing with his thesis of the relativity of the individual. So the individual is only one part of the reality that results from individuation. So we have the total reality, the sunalon, in the original states, that then undergoes a process of individuation, and that results in an individual, but also in the associated milieu. So the individual taken on its own is only a partial reality. And so the method that he is proposing here is one that would start from the complete reality and bring about the process of individuation in that reality, rather than starting from the already individuated individual, which is only a partial reality.
One thing that confuses me a little bit about this section, and I think he says it again on the next page, is the idea that the pre-individual milieu is on the same order of magnitude as the individual. I think this relates to the footnote that Alyosha just posted. But I don't know if that means that the order of magnitude that's on the same level of the individual, is that just the level of the communication between the two different orders of magnitude?
I'm not sure. So the first thing I would say is we need to distinguish between the pre-individual being, or the total reality before individuation, on the one hand, and then the milieu that results from the process of individuation on the other hand. those are not the same thing. He points that out, I think, on the next page, or anyway, somewhere in this section, he points out that we need to distinguish between those two. So there's within nature there are domains that precede individuation, and then there are domains that are the associated milieu of an individuation process, but are not themselves individuated. But yeah, so with that in mind, it's the second one that is that is complementary to the individual, and so it's at the same order of magnitude. So it's the associated milieu after the process of individuation that is at the same order of magnitude as the individual. And so that, and that process of individuation comes about in a structured system that contains the multiple orders of magnitude in which the individuation proceeds as a mediation. So I think we can consider that the associated milieu at the same order of magnitude as sorry, I forgot the exact wording that you used, but as consisting in that mediation between orders of magnitude, between the lower and the higher order of magnitude.
The way I'm reading part of this, so there's a bit in the first paragraph. Individuation then is the structuration of a system without a separation of the individual and its complementary, such that individuation introduces a new regime of the system but does not break the system. And I think, Don, you were basically expanding on that just now. I guess I'm thinking of, so in social sciences, I think they talk about units of analysis, right? Like, what's your unit of analysis? And, in some sciences, it's the individual level. Some sciences, it's the social level, or it may be like an organizational level or whatever. And it seems to me that for Simondon is part of what he's saying here is the unit of analysis always needs to be the system. Like, we always need to talk about the system as a whole, even if we're not, we may be looking at just a region of it, but every property is ultimately a systemic property. You don't have any genuinely individual properties, but individuality kind of grows out of this systemic, the system of relations and potentialities and so on.
Yeah, so to expand on that a little bit, like if you wanted to look at these different levels of analysis, the individual level or the organization or a social level or something like that, for Simondon, in order to be able to do that, you would have to start from the complete reality or the system as a whole, out of which those levels of analysis emerge. So you can only look at an individual level of reality or an individual level of analysis if you start from the system as a whole in which that individual emerges. And so yeah, it's what relationship that has to structuralism. Yeah. I would say, I think, and structuralism means so many different things. It's hard to say exactly, but I think the emphasis on the genetic or dynamic nature of the structuration in Simondon is different than most systems that would be described as structuralist. So it's not that there is a sort of pre-existing system that orders all the entities into a sort of grid or something like that. It's the system itself undergoes transformation, resulting in an individual and its associated milieu or whatever level of analysis or order of magnitude that we're dealing with.
Yeah, one thing I was going to say in response to what Angus was saying earlier, I'm trying to look for the quotes, and I don't know if this would help, but when we think about the individual milieu thing, he talks about them being constituted simultaneously out of a splitting of the sunulon. And there's other places where he talks about the milieu having been robbed of the individual, which I think is a slightly different framing. But I think in either case, it might be helpful to think of it like any time where, this thing of like an inferior reality looking at this larger reality that it is supposedly alienated from, like nature. I think that's the example he gave here. That whenever it's like it's this problem of relating to seemingly given terms that he's saying, but like the milieu, basically the way I understand it, and I wonder if this will be tested by our reading, but the way I understand it is if the milieu and the individual are sort of constituted simultaneously, it's because the kind of milieu that comes into being without the individual, in a sense, in the sense of the individual seeming to have broken off from it, is fundamentally different from the what we would think of as like the pre-saturated, the supersaturated solution filled with potentials in a pre-individual non-phase state. So that kind of milieu is fundamentally different from the milieu after which structuration begins, and then there's individual in some kind of individuality in relation with some kind of milieu. That's sort of how I'm approaching it. I wonder if that helps or hinders.
I don't want to put you all too much off track, because I'm not very far into the Simondon text, but what was just described actually reminded me more of like a systems theory approach than like Luhmann actually, rather than French structuralism. And I found that interesting in this, particularly because I know in the reception in the social sciences of Simondon more through like Latour, who positions Simondon then more or less against the Luhmannian approach, specifically in the sense that he says that Luhmann had the right idea with his systems theory, but the problem is trying to reduce everything to one kind of system or one kind of logic behind the systems and one systematization, instead of understanding the process of doing social science itself as one of the modes of structuration that happens in the whole, more or less. Or you wouldn't say the whole, because the whole is a bit of a problematic category there, but in the process of what's happening in society.
Yeah, that's interesting. I didn't realize that Latour had written about Simondon, but yeah, I'll have to check that out.
Oh yeah, so Simondon is a pretty prominent reference for him, I think, specifically when he talks about like in reassembling the social, where he talks about social scientific methodology and the status of the social sciences. There he's drawing extensively on Simondon.
Okay, so I think we can continue with the next little bit, the next couple paragraphs, if someone else would like to read.
In a certain sense, there is a complete opposition between Leibniz's monad and Spinoza's individual, because Leibniz's world is composed of individuals, whereas Spinoza's world includes, properly speaking, only a single individual, nature. But this opposition in fact arises from the individual's lack of relativity with respect to a complementary reality of the same order of its own. Leibniz fragments individuation down to the extreme limits of smallness, thereby according even individuality to the smallest elements of a living body. Conversely, Spinoza expands individuation all the way to including the limits of the whole, that through which God is naturing nature, that is, individuation itself. There is no mention in either the work of Spinoza or Leibniz regarding a relation of the individual to an associated milieu, no mention of a system on the same order of magnitude within which the individual can receive a genesis. The individual is mistaken for the being and is considered as coextensive with being. Under these conditions, the individual is considered as coextensive. Under these conditions, the individual considered as coextensive with the being cannot be situated. All reality is simultaneously too small and too large to receive the status of individual. Everything can be individual, and nothing can be fully individual. On the contrary, if the individual is grasped not as the term of a relation, but as the result of an operation, and as the theater of a relational activity perpetuated in it, it is defined with respect to the ensemble it constitutes with its complement, which is at the same order of magnitude as it, and on the same level as it after individuation. Nature in its entirety is not composed of individuals and is not itself an individual. It is composed of domains of being that can or cannot harbor individuation. In nature, there are two modes of reality that are not those of the individual, domains that have not been the theater of an individuation, and what remains of a concrete domain after the individuation, when the individual is subtracted. These two types of reality cannot be conflated, for the first designates a complete reality, whereas the second designates an incomplete reality that can only be explained by genesis, i.e., based on the system from which it emerges. If we propose to know the individual relative to the systematic ensemble in which its genesis occurs, we discover that there is a function of the individual with respect to the concrete system envisioned according to its becoming. Individuation expresses a phase change of the being of this system, thereby avoiding its degradation, incorporating the energetic potentials of this system as structures, making antagonisms compatible, and resolving the internal conflict of the system. Individuation perpetuates the system through a topological and energetic change. The veritable identity is not the identity of the individual relative to itself, but the identity of the system's concrete permanence throughout its phases. The true haxiety is a functional haxiety, and the origin of finality lies in this underpinning of the haxiety that it translates into an oriented functionality, into an amplifying mediation between orders of magnitude initially without communication. Thus, in terms of providing an adequate knowledge of the conditions and process of physical individuation, the insufficiency of the matter-form relation leads us to analyze the role played by potential energy in the operation of individuation insofar as this energy is the condition of metastability.
Right, so the reference to Spinoza and Leibniz here, these are sort of two complementary errors for Simondon that both derive from not grasping the individual as relative to an associated milieu. So treating the individual as coextensive with being. And so on the one hand, Leibniz takes every particle of matter to be an individual, so brings individuality down to the extreme limits of smallness. And then on the other hand, Spinoza treats nature as a whole, as an individual, and as the only individual. And in each case, the error derives from not granting or not recognizing that aspect of reality that is the associated milieu that results from the process of individuation and is coordinate with the individual.
So one thing I'm very curious about here, this is just jumping almost at the very end, but the point he makes about finality. So this is the second to last paragraph, last sentence. The origin of finality lies in this underpinning of the haxiety, that it translates into an oriented functionality, into an amplifying mediation between orders of magnitude, initially without communication. And I think I'm trying to understand exactly how finality works here, because I think that sort of the dualism that Non was mentioning, Leibniz and Spinoza, I think often it's put in terms of final causes, right? Leibniz was very big on final causes. And he thought, these monads, each one has a kind of internal teleology. And I think he calls it an entelechy, and then they all kind of connect through God and so on. And I think Spinoza is often read as actually denying final causality altogether. And it kind of sounds to me like maybe Simondon is looking for some kind of middle position here. And I'm trying to understand exactly how do we get final causes out of the individuation process? Because it seems like we do, right? There's some kind of oriented functionality.
Yeah, this bit is pretty compressed, I would say. It's sort of alluding to developments that we'll see in the later in part 2 of the book on vital individuation. But I think what he has in mind here is his criticism of cybernetics and, in general, to mechanistic approaches to the living being, which is basically that, and I think we've seen some reference to this as well, but basically the criticism is that you can analyze the functioning of various organs or components of a living being in mechanistic terms, or model them on the functioning of machines. But that doesn't give an account of the setting up of the whole living being as a whole in the first place. So unlike machines, living beings sort of structure themselves. They bring themselves into being, and all the sort of mechanical components of a living being are the results of that living being itself. So there's something like a finality or goal directedness in that individuation process of a living being. But we'll have to wait till we get to part 2 to have a better understanding of how that works, I think.
Do you think finality could also be understood as like the sort of the completed stable system, in a sense, or of like what we perceive as this given individual with a clear relationship with some external thing? The reason it's perceived as final, he's saying, rather than it being the actual final result of something, it is sort of the resolution of a problematic that I suppose in non-living individuation that does obviously end at some point, but at least insofar as living individuation goes, it doesn't actually ever end. So I don't know if that's, I'm not as familiar with Leibniz, so I couldn't speak on the final cause, because he kind of speaks of it in terms of hexaity oriented towards functionality. I was kind of thinking about his earlier point of, the conservation of being in becoming, the conservation of it through this process. So it's sort of, almost as though it behooves it for it not to be final. Like it's just the end of one phase of the process, I guess, is how I'm seeing it.
Yeah, I think the term finality here does have a connection with the concept of final causes. Yeah, I think it's right that he's trying to find some sort of middle ground between I guess a Spinozist and a Leibnizian position on final causes. So he doesn't want to say that there is no such thing as finality, but he wants to sort of relativize it. It's relative to a living individual and the process of vital individuation. But yeah, like, as I said, we're going to have to wait till we get to part 2 to see this in more detail.
It seems to me like he's treating the milieu in an important sense as a final cause, right? And definitely it would be relative. Like it wouldn't be like an absolute final cause the way you have in in some kind of idealism or like Aristotelian thinking. But I'm also thinking of to mention quickly the other book, The Mode of Being of Technical Objects. Towards the end of that book, he kind of, gives a sort of lots of broad level discussion. And he does talk about a kind of unity that is seeking to reestablish itself. You really get the sense of a kind of circle that seeks to close itself. And the closure is probably never complete, but he will talk the language of unity and of a kind of, like seeking to reestablish a kind of original harmony. So it's pretty dialectical in that sense, but I mean, he doesn't want to call it dialectical. So it's interesting to me how he's sort of on the border between, these different, what we see in, let's say, phenomenology, which is still pretty Aristotelian, like Merleau-Ponty, and then going forward to like somebody like Deleuze. And it seems like Simondon is maybe sort of like a transitional figure there.
Yeah, I think that makes sense in terms of the history. I think you're right about the history. I think Simondon is trying to preserve some notion of final causes, but in a way that doesn't make final causality some sort of separate domain of existence in the way that it can be in like the Leibnizian approach, for example. It's something we'll have to watch out for and try to understand better as we go along. And I think we can move on to the second chapter now. So if someone else would like to read, I believe we have one of these. It's not that long. So yeah, the first medium long paragraph there, if someone could read that for us.
I'll read it. Chapter 2, Form and Energy, Structures and Potential Energy, the Potential Energy and the Reality of the System, Equivalence of Potential Energies, Disc Symmetry and Energetic Exchanges. The notion of potential energy in physics is not absolutely clear and does not correspond to a rigorously defined extension. Thus, it would be difficult to specify if the thermal energy stored in a heated body should be considered as potential energy. Its potential nature is bound to a possibility of the system's transformation through the modification of its energetic state. A body whose every molecule would possess the same quantity of energy in the form of thermal agitation would not possess any quantity of thermal potential energy. Indeed, the body would thus have attained its most stable state. Conversely, a body that would possess the same total quantity of heat, but in such a manner that this quantity would be in one region of molecules at a higher temperature and in another region of molecules at a lower temperature, would possess a certain quantity of thermal potential energy. Furthermore, this quantity of potential energy cannot be considered as eventually added to the non-potential energy contained in the body. This quantity is a fraction of the total energy of the body that can give rise to a transformation, whether reversible or not. This relativity of potential that characterizes energy becomes manifest clearly if it is supposed, for example, that a body heated homogeneously, and thus not possessing any thermal potential energy if it is the sole body constituting a system, can manage to make a potential energy appear if it is put into contact with another body of a different temperature. The capacity for an energy to be potential is strictly linked to the presence of a heterogeneity, i.e. of dissymmetry relative to another energetic support. By resuming the preceding example, we can indeed consider a particularly demonstrative borderline case. If a body were heated in such a way that it contains certain molecules at a higher temperature and others at a lower temperature, and if these molecules are not grouped in two separate regions but mixed together randomly, for a microphysical observer, the body would still contain the same quantity of potential energy when the molecules are grouped in a hot region as in a cold region, because the sum of potential energies presented by all the couplings formed by a hot molecule and a cold molecule would be numerically equal to the potential energy presented by the system formed by the group of all the hot molecules and the group of all the cold molecules. Nevertheless, this sum of potential energies of the molecular pairs would not correspond to any physical reality, to any potential energy of the overall system. For this to happen, it would be necessary to organize the disorder by separating the hot molecules from the cold molecules. This is what the hypothesis of Maxwell's demon shows extremely well, which is taken back up and discussed by Norbert Wiener in his Cybernetics. The attentive consideration of the type of reality represented by potential energy is quite instructive for the determination of a method adapted to the discovery of individuation. Indeed, reflecting on potential energy teaches us that there is an order of reality that we can grasp neither through the consideration of a quantity, nor through the consideration of a quality, nor by resorting to a simple formalism. Potential energy is not a simple way of seeing, an arbitrary consideration of the mind. It instead corresponds to a capacity of real transformations in a system, and the very nature of the system is more than an arbitrary grouping of beings operated by thought, because, for an object, the fact of belonging to a system defines for this object the possibility of mutual actions relative to the other objects that constitute the system, a possibility which ensures that the belonging to a system is defined by a virtual reciprocity of actions between the terms of the system. But the reality of potential energy is not that of an object or a substance consisting in itself and having no need of anything else in order to exist. Indeed, it requires a system, i.e., at least another term. No doubt we must struggle against the habit that leads us to grant the highest degree of being to substance conceived as absolute reality, i.e., reality without relation. Relation is not a pure epiphenomenon. It is convertible into substantial terms, and this conversion is reversible, like that of potential energy into actual energy. I just have a quick question. Maybe it can help us get started with this long bit. I'm just thinking earlier about when he's discussing the plasticity in the clay, and he's talking about the homogeneity of the colloidal properties. But he's also saying that in that case, which I know is different from this, that there's a required homogeneity for there to even be an internal resonance in the first place. And then here he's talking about the need for heterogeneity. I don't actually think these are contradictory, but I know I'm missing a link somewhere. Because I remember I was struggling earlier with the homogeneity of the clay thing, because I would have thought he would have gone for heterogeneity there, but he very explicitly went for homogeneity. Is there anyone who might be able to help distinguish the difference between these cases?
Yeah, I think Angus's comment in the chat there is right. I think in the clay and brick system, you have a heterogeneity between the two orders of magnitude, which is what allows for work to occur in the system for a transformation to come about. And then the homogeneity is necessary for the transmission of forces across the system. So in the case of the heated object that he's describing here, you have the heterogeneity is the difference in temperature, but then there's still a homogeneity in the sense that there's a transmission of heat across the body. So the body is structured in such a way that heat can be transmitted from one end of the body to the other. So yeah, those two sides, the heterogeneity and the homogeneity, are both going to be present in any system, but in different respects or in different ways.
Right. So then in that case, it's sort of like a topological homogeneity, or like I think we talked about surfaces, maybe not in the strict literal definition, but like the homogeneity of creating a space or a field in which, like you said, something like the heat could be distributed equally across the body. But then the heterogeneity, I think here it's saying that relative to another energetic support. So does that kind of correspond to the orders of magnitude thing that you're saying?
Yeah, so the homogeneity is the necessary condition for there to be a system as a whole. So in the case of the clay and the brick, the clay and the molds, it's the plasticity of the clay that transmits force is the necessary condition for there to be a system. In the case of the heated body, it's the conductance, I believe is the term, across the whole body. So whereas if you have one body separated from another by an insulator, then the two don't form a system with respect to heat. So it's always the homogeneity is the necessary condition for there to be a system in the first place. And then the heterogeneity is what's necessary for there to be the capacity of transformation in that system.
It sounds like maybe this is getting also to the difference between what he would think of as matter and what would be energy. Because so the first chapter was called Form and Matter, right? And now we have Form and Energy. And it seems like matter would somehow be akin, or would have to be homogeneous in some sense. And then we don't have energy unless we have this heterogeneity between two orders, or an energetic potential.
Yeah, I think that's right. I was also going to mention here that he's pursuing his criticism of substantialism, or the notion of substance, and so he has Descartes in mind here. That little bit in quotes, where he says, "Having no need of anything else in order to exist," is from Descartes. I think the Meditations, if I remember correctly. So it's the idea that substance is the highest form of reality, or the exclusive form of reality, and relation is like a degenerate form of reality. That's the notion that he's criticizing here in this passage. So he's giving a new argument for that criticism through the use of the notion of potential energy, which is always relative to a system.
Yeah, I had to look up the whole Maxwell's demon personally, and maybe other folks are more well educated than myself, but this thought experiment regarding the separation of molecules, and I thought it was interesting because I through reading about the background, it kind of made sense why Simondon had brought this up, because there's this whole idea of, okay, how if I'm not going to profess to understand it fully, but the thought experiment is about a potential way to sort of like break the second law of thermodynamics or whatever. Because if you actually had this system with this demon able to separate the molecules, something happens. I would love for someone to explain it to me. But one of the interesting observations that I saw from reading that background is that there was, back and forth critiques of this thought experiment, and lots of different people over the years have had their responses. But one of the common, and I think one of the responses that Simon is kind of channeling here, the problem of measurement, right? So the idea in this thought experiment is that the demons, this is somehow is able to tell which molecules are what. Like, this is a hot molecule, this is a cold molecule. I'm going to let these ones through because the hot ones are faster, and these cold ones in here because they're slower. And the problem with this is that the demon has to have a way of measuring those properties in order to be able to determine those things. So then the thought experiment kind of doesn't exactly work or do exactly what it says, from what I understand, because that if you don't account for it's like sort of the topological information thing that someone has talked about before. There has to be measuring implies interacting with the energies in the system in order to know them, or in order to understand what they're doing transductively, you might even say. So again, I'm sorry for that being garbled, but I just thought that if anyone has more on Maxwell's demon, I thought that might be helpful as well.
Yeah, that's a good point to bring that up. And so as Angus has mentioned in the chat here, the sort of the points or the counterintuitive results of the thought experiment is that if you could have something like this Maxwell's demon that could separate the hot and the cold, or high energy and low energy particles, then you could sort of reverse the course of time. You could take a system that is homogeneous and have it turn into a heterogeneous system that could then perform work again. And so you could have a perpetual motion machine, basically, that would perform work and then separate out the high and low energy particles again, and then perform work again, and so on. So yeah, that would violate the second law of thermodynamics. And yeah, you're right that the general critique of this is that the Maxwell's demon would have to the demon creature would have to perform work in order to measure and separate the particles in the first place. And so there'd be no way to have the system as a whole, including the daemon, separate out high and low energy states. It would be there has to be an input of energy in order for that separation to happen, and so you can't produce a perpetual motion machine through this procedure. Right, and I think that's what that passage from Wikipedia that you posted there, Alyosha, is mentioning, that once you take the daemon into account as part of the system, because it's interacting with the particles, then the total entropy of the system as a whole is increasing, even though if you only look at the particle and not the daemon, then you would see a local decrease of entropy.
I wonder if that's helpful for us overall, because even the image I pasted there from Wikipedia, it's as though relation is typically talked about in a way where this daemon is precisely this thing relating these two sides of these two terms, and it's a sort of non-essential part of this systemic relation. It's just something that is a line between them, and it's not intrinsically affecting them in any way. But I think that's what he'll kind of go into in this chapter, that this idea of the rapport of the three terms, that there's not really such thing as just kind of two terms relating without there being some other kind of support. And I don't know if it's reaching as well, but I just wanted to mention what I was saying before in chat, that like, this is why I really liked his point about functional hexaity, that it almost seems to connect back to his idea of transduction and transductive knowledge as well, that like there is no way of partaking in the hexaity of the thing, of apprehending it in a non-functional way. I don't just mean that socially either. I mean in the sense of sort of like to apprehend it and to begin to parse what it does is sort of it's sort of similar to that process where there's no measuring that does not involve being put into relation with this larger system between individual milieu and all this stuff that like I guess that's what it is as a philosophical move. That's what transduction is supposed to be, or transductive knowledge is taking the veil away from that operation and making it apparent. But just that, yeah, the thing that appears to us like it's hexate or it's quiddity is precisely that, because of our functional relationship with it, rather than just a sort of base observation. I just think that's really interesting.
Yeah, and importantly also at the same time, so even though these notions like potential energy are relative to a system, they aren't any less real because of that. So there's a real possibility of transformation in a system, which is not dependent on our knowledge of the system, but it's relative to the system, but it's not relative to our knowledge of the system. So it's not any less real. So yeah, I think that's it's sort of a difficult concept to or a different mindset to put yourself into, to try to grasp relations as having the status of reality, as he puts it, and just trying to hold on to the reality of these relative concepts.
To go back to the historical point Leibniz and Spinoza, it seems like they both make the same mistake, which is that they don't really understand this relation that is not a pure epiphenomenon. So I guess they do it in different ways. Like Leibniz goes down to the very small, right? The monads, and Spinoza goes up to like the totality, right? The one nature. But it seems like, and maybe a question like, is this the way to think of it? That really they, in a way, the heterogeneity is between those two orders, it seems like. It is between the small and the large. I think Angus has been bringing that up with like the disparate orders. And I wonder if, in a sense, like to get to where Simondon wants to be, you kind of need both Leibniz and Spinoza.
Yeah, I think that's a good way of looking at it. So they're both they make Spinoza and Leibniz make the sort of complementary errors, which both result from that incapacity to grasp the individual as relative to an associated milieu, and therefore an incapacity to grasp something as both relative and real. And so Leibniz will just deny that there are relations at all. Each monad is self-contained. It has no windows, as he puts it. And then Spinoza will sort of incorporate everything into one individual. So there's no relation in that sense either. But yeah, so that's a good way of putting it, I think, is trying to grasp both of them at the same time, both Leibniz and Spinoza at the same time.
Right. So it sounds like they both they want a kind of homogeneity. They don't want to, it seems like there's something about heterogeneity that's just difficult, and that philosophers are generally kind of allergic to. And it seems like, Spinoza wants the heterogeneous one of nature, and Leibniz wants this sort of, the homogeneous one. And with Leibniz is similar, but on the small scale. And yeah, that's kind of making sense to me.
Right. So I think we can go on to the next couple paragraphs and start talking about pendulums and how they work. So I can read the next couple paragraphs here. And there's diagrams too for those of you who aren't looking at the text right now. There are some diagrams in the text that are helpful as well. So you can see those on my stream. If a distinction of terms is useful for determining the results of the analysis of significations, relation can be called the arrangement of the elements of a system that has a scope surpassing a simple arbitrary view of the mind. And we can reserve the term of rapport for an arbitrary, fortuitous relation that is not convertible into substantial terms. Relation would be a rapport just as real and important as the terms themselves. Consequently, it could be said that a veritable relation between two terms is in fact equivalent to a rapport among three terms. We shall begin with this postulate. Individuation requires a true relation, a relation that can only be given in a system state that envelops a potential. The consideration of potential energy is not merely useful insofar as it teaches us to think the reality of relation. It also offers us a possibility of measure through the method of reciprocal convertibility. For example, let's consider a series of increasingly complicated pendulums, and let's attempt to note the transformations of energy of which they are the source during a period of oscillation. We shall see that we can confirm not only the convertibility of potential energy into kinetic energy, then into potential energy, which is converted back into kinetic energy, but also the equivalence of two different forms of potential energy that are converted into one another through a determinate quantity of kinetic energy. First, take for example a simple pendulum labeled OM that oscillates in the Earth's gravitational field, figure 1. If A is the point of the trajectory closest to the center of the Earth, and if B and C are the extreme symmetrical positions relative to the axis OA, the potential energy is at a minimum in A, and the kinetic energy is at a maximum. Conversely, in B and C, the potential energy is maximum, while the kinetic energy is minimum. If the horizontal plane passing through point A is taken as an equipotential surface of reference, and the axes of mobile coordinates with respect to point O are considered as a system of reference for measuring the displacement of the axes of the immobile coordinates, it could be said that potential energy is null in A and kinetic energy null in B and C. These two forms of energy are thus transformed into one another completely, at least if we neglect the degradation of energy caused by friction. Now let's take the case of a pendulum like the one constructed by Holweg and Leger that enabled the establishment of the gravimetric network in France, figure 2. The lower part of this pendulum is made of an elastic wire encased in elinvar, and the upper portion involves a chunk of quartz. The connected pieces are placed in a vacuum tube in order to reduce damping. The operative principle at work here is the following. When the pendulum is distanced from its position of equilibrium, the momentums of the elastic forces and of the forces of gravity act in opposite directions, and through a suitable adjustment, we can bring these two momentums to being only slightly different. Since the period is determined by the difference of these momentums, it can be said that what has been created is a system allowing for the conversion of one form of potential energy into another form of potential energy via a certain quantity of kinetic energy that is equivalent to the quantitative difference between these two potential energies. If the two potential energies, that which is expressed through the momentum of elastic forces and that which is expressed through the momentum of gravitational forces, were rigorously equal, the pendulum would have a period of infinite oscillation, i.e. would be in a state of indifferent equilibrium. Everything occurs as if the potential energy that is effectively converted into kinetic energy and then reconverted into potential energy during an oscillation were an energy resulting from the difference between two other potential energies. The same pendulum brought back to 180 degrees would, on the contrary, bring about an addition of two potential energies in the form of kinetic energy at the lowest point of the trajectory traversed by the chunk of quartz. Right, so I scroll back up to the diagrams, which are unfortunately not on the same page as the texts themselves. But so for those of you who are watching the stream, you can see point A is the lowest point of the pendulum, so the point closest to the center of the Earth. And then you have points B and C are the maximum points, the maximum distance from point A. And then, so at point A, when the pendulum is at point A, it has a minimum of potential energy and a maximum of kinetic energy. And then at points B and C, it has a minimum of kinetic energy and a maximum of potential energy. So that's what, yeah, they didn't actually translate the diagram, which is unfortunate. So EP max means potential energy maximum. EC minimum is the kinetic energy minimum. And yeah, so that's what's going on with that first pendulum. Now the second one is more complicated, but the idea, as I understand it, is that it has to do with the period of oscillation of a system of pendulums that are coupled to each other. So let me just go back to the text here. Right, so you have a flexible piece of metal, I suppose it is, that you have a displacement of one end of the pendulum, and then you have force of gravity, and then the flexion, elastic forces of the pendulum itself are acting in opposite directions, so that you end up with the motion, the two momentums of the gravitational force and the elastic force are operating separately from each other, and then you can adjust the pendulum so that they're so that they converge towards each other, and then you can the period of the pendulum will be a result of the two momentums of the gravitational force and the elastic force.
Yeah, my understanding of my probably simplistic understanding of the inverted pendulum is just that like gravitational force wants to pull the mass to the sides, so that the heavy quartz is as low as possible, and then the elastic force of the spring wants it to be straight up. So there's this tension between the two different kinds of potential energy.
Yeah, so that's the sort of the mechanism is you have the sorry, let me scroll up to the diagram again. You have the heavy quartz head, I guess, of the pendulum is being, once you displace the pendulum to the side, then that it will be pulled down and outwards by gravity, whereas the flexion of the pendulum of the actual body of the pendulum will be pulling it back towards the center. But so that's the sort of the basic mechanism. But what he points out here is that you can adjust. So I guess it would be based on the length of the pendulum and the weight of the quartz. You can adjust the period of the flexion. The pendulum will, if you displace one end of the pendulum, it'll sort of swing back and forth, and you can adjust the period of that swing based on adjusting the properties of the pendulum. I believe this is used. So he says it has to do with the gravimetric network in France. So I think you can use this as a means of measuring gravitational force if you have a known. If you know the properties of the pendulum, you could use it as a means of measuring gravitational force. But I'm not 100% sure if that's what this is used for. Oh, that's interesting. Yeah. So Angus pointed out in the chat that oil companies used to use these types of pendulums to do gravimetric maps. So I guess depending on the density of what is underground, you would have slightly different responses of the pendulum, and so you can use this to determine what is underneath, under the ground, and where to do exploration and so on. Okay, so let's go on to the next. Let's see. Yeah, we have another long paragraph, I think. So if someone else would like to read that, and then we'll take a look at the diagrams again.
Ultimately, we could constitute a more complex system of pendulums, coupled together without damping, weighted pendulums or torsion pendulums, figures 3 and 4. In this case, we would witness beats on each pendulum, and these beats would be more spaced out according to how weak the coupling would be. These beats themselves occur in a manner of quadrature, i.e., because each of the pendulums seems to stop when the other reaches its maximum, the energy of the oscillations is transferred alternatively from one of the pendulums to the other. In a similar experiment, can we still estimate the period of the resulting oscillation? Transfer of corresponds to a determinate potential energy. Yes, because if K designates the coefficient of the coupling between the oscillators that the two pendulums constitute, and omega designates the pulsation of these two pendulums, which is supposed to be the same for both. The period of the beats on the two pendulums is given by the expression. Here, potential energy resides in the fact that initially one of the two pendulums is animated by a movement, whereas the other pendulum is immobile. This dissymmetry is what causes the passage of energy from one pendulum to the other. If pendulums with the same appropriate frequency, animated by synchronous oscillation and with the same phase, were coupled, the appropriate resulting period would not be the same as the period of the oscillation of each of the separate, and yet no exchange of energy would take place. There is a beat in the case where the dissymmetry of the initial conditions of the exciter and of the resonator can be nullified and transformed into its inverse, and then can return to the initial state. And that formula there was T equals 2 pi over K times, and I think is that omega, the Greek letter?
Yeah, so let me scroll back up to the diagrams, which again are not translated, but it's pretty straightforward, this one at least. So you have two pendulums that are coupled to each other. They have this shared wire, and whatever the so each pendulum has its own proper frequency or period, and the coupling of the two pendulums will will cause the two pendulums to synchronize at a different period than they started with. And so that expression t over 2 pi, t equals 2 pi over k omega, that gives the period of the beats between the oscillation of the two pendulums. So yeah, that's even though there's no transfer of energy from one to the other, they still end up being synchronized to each other. Yeah. So just to be clear, I didn't state this as clearly as I should have. But yeah, so there's two different cases that are being discussed in this paragraph. So the one case is where you have the Disc Symmetry. So you have one pendulum in motion while the other one is stationary, and in that case there is transfer of energy because you have that dissymmetry. And then the second case is when you have two pendulums with the same frequency that are synchronized, but in that case you end up with a different period of oscillation, but no transfer of energy.
One of the reasons why the synchronization happens is that there is a common plan. There is I think the guy who discovered this, I think it was Huygens, and he found that if the pendulums are not standing on the same platform or connected somehow by a medium, they don't, obviously they don't do this. So it's not like an air or some kind of pure energetic. So it's interesting, I guess. I mean, my reading of that would be there needs to be some homogeneity between them. There needs to be some conduit, as it were, that can transfer. I guess in this case, there's a kinetic energy. So it's interesting. It seems like, at least, I mean, if that's true, then some like homogeneity and heterogeneity have some kind of dynamic.
Yeah, the homogeneity is the necessary condition for there to be a system in the first place. And then the heterogeneity is the necessary condition for the transformation to occur within that system. So both of them are necessary for there to be a system undergoing transformation. Okay, so let's go on to the next couple paragraphs to the end of the subsection here. If someone else would like to read.
We could multiply the increasingly complex cases of energetic exchanges. We would find that that potential energy always seems to be bound to a system's state of dissymmetry. In this sense, a system contains potential energy when it is not in its state of greatest stability. When this initial dissymmetry produces an exchange of energy within the system, the modification produced can be transformed into another form of energy. In this case, the system does not immediately return to its initial state. For it to return there, the preceding transformation would need to be reversible. In such a case, the system oscillates. This oscillation establishes the equality of two forms of potential energy. Thus, we can already distinguish the identity of two energetic states from the equality of two energetic states in the case of potential energy. Two potential energies are identical when they correspond to the same physical state of the system, with merely a difference of measurements that could be suppressed by a suitable displacement of the axes of reference. Therefore, when the pendulum of figure 1 oscillates, it establishes the reciprocal convertibility of the potential energy corresponding to position B and of the potential energy corresponding to position C. Since the measurement of potential energy of the Earth pendulum system only depends on the position of mass m with respect to the equipotential surfaces, which are in this case horizontal planes, the determination of position B or position C only depends on the direction chosen for the measurement of elongation. The inversion of this relation makes it possible to identify the physical states corresponding to states B and C for the measurement of potential energy. By contrast, let's consider the example of the Hall-Wickledge pendulum. It is no longer possible to identify through a simple displacement of the conventions of measurement the states of potential energy corresponding to the couplings of the forces of gravity and those corresponding to the elastic forces that come from the bending of the Ellen-Bar wire. The oscillation, however, establishes the reciprocal convertibility of these two forms of energy, and this leads us to consider them as equal when the pendulum state of indifferent equilibrium is found to be realized. Potential energy defines the real formal conditions of the state of a system.
Yeah, so I think the key takeaway of this subsection is that bit that in that first paragraph that we just read, that's italicized, that potential energy always appears as tied to the state of dissymmetry of a system. So there's always, it's only when there's that dissymmetry within a system that there's potential energy. So that's the sort of key thesis of this subsection.
So can I ask, I might be remembering this wrong. There was an aspect when he's talking about individuation and transduction, like earlier on in the book. I don't know if he uses the word reversibility, but there's a way that he's distinguishing, thinking about our earlier discussion of dialectics and stuff. He's distinguishing different methods, and he's talking about the problem of, sort of thinking in dialectically in stages involves sort of the negation of information and sort of the removal of previous states, whereas what's happening in his account is that things are preserved, and if anything, they only grow. This reminds me of the Bergsonian thing we've talked about in that class of, how could the result be sort of greater than or larger than the thing which caused it. That it was previously thought it always had to be in reverse, or else it's like violating scientific laws. So I'm just thinking here when he's talking about reversibility, if I'm not wrong about that, is it that he's talking about reversibility purely on the level of sort of the distribution of energies? So if we go back to the clay example and the homogeneity of like the surface or the colloidal properties that allow there to be the even distribution of work throughout it. So in that case, the reversibility there refers to the ability of that, like basically the internal, rather than because in principle you can't reverse like the individuation that occurs, right? That's kind of like the point or the the crystal or any other kind of individuation, is that there's no sort of just undoing the terms and sort of starting again from the beginning. It's that the original terms are still there, sort of like conserved in the center as the seed grows, outwards. I don't know if I'm making sense here, but I basically the way my mind works when I see terms that I feel I've seen elsewhere, I latch onto it and I'm trying to make a difference so that I can understand it.
Yeah, so here he's talking about reversibility so this reversibility is a particular property of these systems, these oscillating systems like the pendulum or the sets of pendulums. So it's only in a system that does have the property of reversibility. So the pendulum swings one way and then it can swing back to its initial state. Only systems that have this property of reversibility will be oscillating systems that will produce some sort of regular repeated phenomenon, whether it's swinging a pendulum or I don't know, pulses of electricity or whatever it is. And so yeah, this is particular to these types of systems that he's describing here. Are they capable of individuation? My guess or my inclination would be to say no, just because that process of transformation, because it's reversible, it doesn't result in something like an individual. So there's no there's no individuation process because there's nothing that is sort of maintained after the transformation has come about. The transformation can just be reversed in the other phase of the oscillation.
I'm interested in a couple of distinctions that. So one of them is the one between identity and equality we see, and it seems like so the passage is, thus we can already distinguish the identity of two energetic states from the equality of two energetic states in the case of energy. And it seems like identity is, I mean, when two states are identical, it seems like they're really the same state. And it's just a matter of, we're framing it in terms of different coordinates, but it's just a kind of difference of language, not a difference of, the things themselves. And it seems like equality actually gets to the things themselves. So there is an actual distinction there. So that's interesting how, it's almost like equality is ontological and identity is just logical. It's just a kind of playing with words or with expression. And it was reminding me of, there's a distinction earlier that he kind of just throws in there between relation and rapport. I don't know if people noticed that. So this was right before the pendulums. And it seems like it's getting to something similar. Again, like maybe like a rapport seems to be more surface and relation seems to be something ontological.
Yeah, he introduced that terminology in the introduction, I believe. The rapport and relation. So relation is what has the status of being. So it's ontological, as you said, whereas a rapport is an external relation or something that is logical, like you said. So that's just a sort of terminological stipulation from him that he set out in the introduction, and it comes up, a few times over the course of the work. And then also, so going to that distinction between the identity and equality of states of potential energy. So in the case of the pendulum, the first one, when we had the points B and C that are the two extreme points, those two states are identical from the perspective of the potential energy of the system because they're just mirror images of each other. So you can just transform one state to the other just by starting your measurement from one position versus the other one. So it's purely a question of your frame of reference for your measurements that determines whether you count something as position B or position C. So those two states or those two measurements are identical, considered as states of the system of potential energy. But then he points to the alternate example in that second pendulum, the inverted pendulum. In this case, you have two different states of the system that are equivalent or that are equal, but not identical. So there's no transformation of the frame of reference that can convert one to the other, but because they can equalize physically, they can be in equilibrium with each other. You can measure those two states as being equal. So yeah, that's the difference between the identity, which is always relative to a frame of reference, and then the equality, which is a physical relation between these two states. Right. Okay. So let's go on to the next couple paragraphs in the next subsection. If someone else would like to read.
Section 2, different orders of potential energy, notions of phase changes and of the stable and metastable equilibrium of a state. Taman's theory. The potential energies of the three physical systems we have contemplated can be said to belong to the same order, not merely because they are mutually convertible during one of the system's periods of oscillation, but also because this conversion occurs continuously. It is this very continuity of conversion that permits the latter to be an oscillation in the proper sense of the term, i.e., to be effectuated according to a sinusoidal law in terms of time. It is indeed necessary to rigorously distinguish between a veritable oscillation, during which there is a conversion of one form of energy into another form of energy, which defines a period depending on the potentials in question and on the system's inertia, and a mere recurrent phenomenon, during which a phenomenon that is non-recurrent by itself, like the discharge of a capacitor through a resistance, unleashes in its occurrence another phenomenon that brings the system back to its initial state. The latter case is that of phenomena of relaxation, which are called, perhaps misleadingly, oscillations of relaxation, the most contemporary examples of which are found in electronics and oscillator assemblages utilizing thyrotrons, or in multivibrators, or even in naturally occurring geysers. Nevertheless, if the existence of veritable oscillations in physical systems can allow us to define those energies that can be submitted to reversible transformations, and therefore can be equal by their quantity as potential energies that are equivalent in terms of their form, there are also systems in which an irreversibility of transformations manifests a difference of order between potential energies. The most well-known irreversibility is the one illustrated by the research of thermodynamics and what the second principle of this science, Carnot's principle, states concerning the successive transformations of a closed system. According to this principle, the entropy of a system increases in the course of successive transformations. The theory of the theoretical maximum efficiency of heat engines conforms to this principle and verifies it, to the extent that a theory can be validated by the fruitfulness of the consequences that can be drawn from it. But this irreversibility of the transformations of mechanical energy into caloric energy is perhaps not the only irreversibility that exists. Furthermore, the apparently hierarchical aspect implied in this rapport of a noble form to a degraded form of energy runs the risk of obscuring the very nature of this irreversibility. Here we are dealing with a change in the order of magnitude and the number of systems in which this energy exists. In fact, energy may not change in nature, yet its order may change. This is what happens when the kinetic energy of a body in movement is transformed into heat, as in the example often cited in physics of a lead bullet colliding with an undeformable plane and transforming all of its energy into heat. The quantity of kinetic energy remains the same, but what the bullet's energy was in its entirety, considered with respect to the axes of reference for which the undeformable plane is immobile, becomes the energy of each traveling molecule relative to the other molecules within the bullet. What has changed is the structure of the physical system. If this structure could be transformed in the inverse direction, the transformation of energy would also become reversible. Here, irreversibility stems from the passage of a unified macroscopic structure to a fragmented and disorganized microscopic structure. The notion of disorder further expresses microphysical fragmentation itself. If molecular displacements were truly organized, the system would in fact be unified. The macroscopic system formed by the bullet in movement relative to an undeformable plane, and by this plane can be considered as an organized set of molecules animated by parallel movements. An organized microscopic system, in fact, has a macroscopic structure.
Yeah, I actually hadn't read ahead to this part, but this feels like it's directly answering the question I had. So this is really helpful. It seems to me like it's back to the question of magnitudes of order, that in the crystallization example, that it is precisely because of the switch between order and magnitude that it's irreversible. That seems to me kind of what he's getting at.
Yeah, the irreversibility is always a result of the difference of order of magnitude. So in the case of the bullet striking the wall, um, um, and then all the energy of the bullet is transformed into heat. You have a coherent macrophysical system which is in motion together, which is then transformed into a fragmented microphysical system where each component or each molecule is in motion relative to all the others. So you pass from a higher order of magnitude to a lower order of magnitude.
I don't know if he'll get to this, but do you think it applies the other way around as well, from a smaller order to a larger order? If it is even possible to distinguish these things not happening simultaneously, just sort of like in his logic.
Yeah, taking to the question just now, like in terms of reversibility, I'm wondering like Simone is following linearity of time, like just like.
We lost you, Ollie.
Sorry, I just thought of the movie Tenet. So the explanation here is fantastic, but at the same time, it's just like following linearity of time, temporality.
Yeah, I think for Simondon, the linearity of time is a result of the process of individuation and of the transformation of a system more generally. So he makes sort of allusions to this in the introduction, but time, he argues that time is a result of the dephasing of the pre-individuated being. And so in this case, time is the result of the transformation of the system. So rather than starting from linear time and then having transformations occur in it, it's the other way around. It's that transformations produce time.
So sorry before my ignorance of physics, but even though Simondon was engineer, so I mean he must have known better than me. But at this moment, I think in 1950s, I think he was stuck to like bound to the thermodynamics than the quantum physics. So actually, his explanation makes sense, but at the same time, like there could be more possibility. Maybe we can discuss this one further later. But just a quick thought about this.
Yeah, I think this will come up more when we get to I think it's the next chapter, when we talk about quantum physics and relativity as well. And so the notions of time will come up there.
Thank you, very helpful.
Yeah, I just wanted to pick up on something. I think Alyosha was raising this earlier. I am wondering about the difference between the veritable oscillation versus the merely recurrent phenomenon. And so the veritable oscillation seems to be defined by a conversion of one form of energy to another. And I guess I'm trying to understand how that is connected. I guess we established that would be linked to these multiple orders or different orders of magnitude. And I'm trying to sort of understand, like if we go back to the that pendulum, the second pendulum, I don't remember the name of it, but the one where we have a veritable conversion, it seems, right, between I guess it's kinetic and gravitational energies. I guess I'm trying to I'm not really sure where in that example the conversion is becoming manifest. Like like it's hard for me to sort of point to the phenomenon, and wondering if anybody has any hints.
In the pendulum examples, all dreams?
For example, yeah, I mean, any example, I guess, would work.
As I understand it, it's like in the case of the first pendulum, like the simple single pendulum that's not inverted, the potential energy is converted into kinetic energy as it goes from like the extreme back down to the middle, which is then gradually converted to potential energy again as it reaches the other extreme. And that might be the reversibility. I'm not sure if other people agree.
So basically, energy there is manifested in motion, basically, right? So I guess we have the maximum kinetic energy when the velocity is the greatest, and then minimum kinetic when the pendulum basically comes to like an instantaneous stop, right? But then at that point, it has the most potential.
Yeah, that's my understanding of the how that conversion works in that pendulum.
Yeah, I don't understand capacitors, but it seems like this capacitor example contrasts to the pendulum, because it seems like that veritable oscillation requires there to be a kind of, the energies are being reconverted back into each other in a sense, back and forth continuously, versus what sounds like he's describing, like another process can be triggered that then returns the original, I don't know what he's saying, he's saying the capacitor here, but returns things to an initial system state, but that doesn't happen through sort of like the same energy being reconverted back, but another phenomenon. Maybe somebody who's an engineer can explain better, but I would imagine the pendulum example doesn't work because it just kind of keeps going back and forth, unless you had another force, like a Rube Goldberg machine that's triggered that then sends something back to the pendulums that would kind of mess up the continual process. Like, I don't know, a firework. I'm not sure.
Yeah. I think what you put in the chat, Alyosha, I think that's right. Is that so? In the oscillations, though, in the case of the pendulum, you have the same energy that's being converted from potential to kinetic energy back and forth. Of course, in real cases, you would have friction, and so you would eventually the oscillation would stop. But in the ideal case, you just have the same energy becoming potential and kinetic back and forth. Whereas in the case, so he mentions, just sort of in passing, he mentions these natural fountains, and so that's an instance of this relaxation process. So it's in those fountains, you have a buildup of some sort of gas in underwater, and then once it reaches a certain threshold, it pushes, the pressure reaches a certain threshold, it pushes the water up into the air, and then allowing the water out, or that sort of explosion of the gas reduces the pressure again, and then the pressure will build up again and produce another explosion. But it's not the same energy that's passing back and forth. It's there's a constant input of the gas that's leaking from a cave underground or something like that. So it's even though you have something that looks similar in terms of recurring phenomenon, coming back to the same state, it's produced in a different way by a constant input. So that's how I understand the difference between these oscillators and relaxation systems.
So constant input is important, right? Constant input. So yeah. The question was like in terms of kinetic energy and then potential energy. So where does it come from? So what I mean is like in terms of the potential energy and the why and how the thing was there, and then how does it have that energy? And in terms of how can it be possible to have constant input, something like that?
Yeah, there can only be that constant input in an open system. So a system that is receiving energy from outside. So that's a necessary condition for there to be something like a relaxation system, is that it's an open system, whereas an oscillator in the ideal case could be a closed system where it would keep oscillating back and forth without any input of energy from without.
I guess I'm trying to understand. I'm wondering, maybe taking a step back a little bit, how this is going to be relevant. And I guess, I mean, I'm sure he'll come to this later in this chapter. But it seems to me like, so ultimately the significance of all this will have to do with ontogenesis, right? And this heterogeneity of energy, of potential energies, would be really the kind of, that's how he's going to define metastability, it seems. And so, because he does say in the opening sentence, I think it was, that, in physics, energy is not really, or I think it was potential energy, is not really well defined. And I suppose ontogenesis will be the kind of milieu where, for him, energy really makes sense, or it's kind of like, that's where potential energy really fits. So yeah, I'm just wondering about sort of the shape of the argument.
Yeah, so as we'll see this in more. We'll get a better picture of the arguments as we continue next week, I think, because he's going to get into transformations of state of matter from liquid to solid and back and forth and so on. And so he's going to come back to that crystallization example that he introduced in the introduction, and that's one of his sort of favorite examples. He's going to explain that in terms of potential energy and the relation between the potential energy contained in the system and the transformation that comes about through crystallization. So yeah, we'll see the structure of the argument more next week.
Yeah, I was just highlighting this last sentence key here, that an organized microscopic system in fact has a macroscopic structure. That seems to be getting into all the questions we've been talking about in terms of orders of magnitude, disparation, the relationship of individual and milieu, the relationship of individual to the pre-individual state that produces it. Like, I feel like that's a theme that's going to keep coming up.
Yeah, so I think we can leave it there for today, and then we'll pick up from there next time, and we'll learn a lot more about crystallization, more than you probably ever wanted to know, but there's a lot of detail about how the crystallization process works. So that's going to be fun. So thank you, everyone, for your participation, and see you all next week.